Today we're going to talk about probability. What do you guys think of when you hear the word probability?
Something will not happen.
The chances of something happening. Lottery, probability.
That's like a million.
It's like 1 in a million or 1 in a couple of million. Okay? What else do you think of with probability? Besides lottery, where else do we use a lot of probability?
McDonald's. What's probability that I'll eat all the chicken nuggets?
Okay? A lot of probability is seen in gambling. That's the biggest place you see probability. Guys, I need you to quiet down. Sophie. Andrew, come to the front. Okay? So, probability is seen a lot in gambling. It does lead to statistics, which is used in a lot more places. But most of what we're going to focus on today is like working with cards or working with dice, because probability is largely used in gambling.
Are you going to teach us how to cheat at Texas Hold'em?
No. I do not know how to cheat.
Road trip to Vegas. We all just come home with millions of dollars.
So, Daniel already gave us a great definition for probability. The chances of something happening, I'm going to say it a little more mathematically. The chances of an event happening. And they use the word event to describe a lot of different situations. An event is just something we want to happen. If we flip a coin, our event might be that we want heads to happen, or our event might be that we want tails to happen. Or if we have a deck of cards, our event might be that we want to pull out a black card from the deck of cards. Or if we roll a dice, our event might be that we want to roll an odd number.
So is our assignment kind of like fun today? Ish?
No.
Like, well, because it's probability, so like deck of cards, you know.
You'll actually get to use a deck of cards today. So, again, we have a new notation. Just like last time, we had some new notations with our formulas, right? Okay? We have this new notation where we put a giant P in front of some parentheses. So what do you think the giant P stands for?
Probability.
Probability. P is the, and it's asking us specifically to find the probability.
Barton, what period do you have in?
2A. Okay, so probability overall is pretty easy. It's just division. The probability of some event happening is the total number of outcomes on the bottom. And on the top is the number of outcomes that we want. We call it a favorable outcome. So probability is all about division. Well, if we're going to work with probability, and if we're going to be working with our decks of cards, we need to know what kind of cards are in a deck of cards. In the past, I always assumed everyone knew what was in a deck of cards, but not everyone plays cards.
52 cards in a day.
Okay, so in a deck of cards, somebody has already said the total. How many total cards? 52. 52. 52 total cards.
We don't have those. We have 4 clubs.
Okay. But they're split into groups. What are some of the groups we can split cards into?
Red and black.
Okay. Red and black is our biggest group split. Then we have clubs and hearts and diamonds. So first we would say red and black cards. How many red cards are in a deck of cards? 26. It's half the total deck.
I was about to say, what's half of 54? I was close.
So 26 black cards, 26 red cards. And then Brighton started naming some of the suits. What kind of suits?
Clubs.
Clubs?
Diamonds,
Hearts.
hearts.
Spades.
Hearts.
Hearts.
I always forget that one is clubs.
Clover is the same as clubs. Some people use a different name for it. So red cards can be split up even further. We have 13 hearts. which is represented with a heart symbol. The card will actually have a red heart on it to show this is a heart. 13 diamonds. That's also represented with a picture, just a diamond. Black cards, we have 13 clubs. And the reason it's called clovers is because it's represented by a 3-leaf clover. Not my best 3-leaf clover ever, but you get the idea. And then 13 spades. They're represented by like an upside down heart. So that's one way to split up our deck of cards. There's also a second way to split up our deck of cards. We have 4 of each type of card. So we would have 1 heart, 1 diamond, 1 club, 1 spade. So like we'd have 1 ace of hearts, 1 ace of diamonds, 1 ace of clubs, 1 ace of spades, 1 2 of hearts, 1 2 of diamonds, 1 2 of clubs, 1 2 of spades. So we have 4 of each kind. Starting with an ace. Then we have 2. How high do the numbers go?
8 to 9, 10.
Close. 10. 2 to 10. And then what do they use after 10 instead of 11?
Jack.
King.
Jack,
Jack.
Queen, King.
I'm really good at drawing cards.
Okay?
So is the ace like a 1?
The ace can be considered, it depends on what game you're playing. A lot of the times it's considered as a 1. It could also be considered as higher than the king, so more points than the king.
11.
Or if you're playing blackjack, it's considered as 11 points.
Blackjack is pretty hard.
It depends on what game you're playing, maybe, but not today.
They promote gambling in schools. Oh my
You
goodness,
would
it's
agree on
awesome.
whoever you're playing with, you decide at the beginning. Is the ace going to be a 1 for this game, or is the ace going to be... Most of the time in war, though, they consider ace the highest card.
But who plays war anymore?
I do.
Okay?
That's what it is.
So, I need you guys to quiet down again. What do we consider Jack, Queen, and King? They also have a special name for that group of cards.
They're
Royalty or
face cards.
face cards.
I know too much.
We know the gamblers in the room.
Yeah, I
And
just
always who
kinda
comes down on whatever they get.
Do not play poker with Brighton.
You will lose.
I don't know.
Okay? So, now that we know what a deck of cards consists of, we can start finding some probabilities. Steve, go away.
Bye, Steve.
Steve, see you later.
I don't bat for that team. I'm sorry.
Okay? Okay, so to actually find the probability, it's just division. We are just dividing. So we have to figure out what number goes on top, what number goes on bottom. So we said the top was the total number of favorable outcomes. That means what we want to happen. What do we want to happen with this probability? We want a face card. That's why they put,
Too easy.
Brighton, Sophie, we want a face card. That's why they put that information in the parentheses. So we need to know how many face cards in a deck of cards. We know a Jack, Queen, and King count as a face card. How many do we have of each?
12 out of 52.
4. So we have 12 total face cards. Okay.
Out of 52.
Then the bottom was the total amount we have to choose from. So how many total
52.
cards? 52.
Are we counting hearts?
No, I do not know how to count cards. I'm sorry.
You would teach us stuff?
If I knew, I would
I was
teach you,
like,
Daniel.
she-
So that you could get arrested in Vegas.
Unless they don't
Okay?
catch you.
Okay, so when we talk about our probability, we can represent it a couple of ways. We can represent it as a fraction, but we also often represent it as a percent. So fraction-wise, I do want you to reduce this fraction. So-
26.
We could divide by 2, but if we divide by 2, we only get 6/26. That is not as reduced as we can be. What else could we
Okay, so
divide?
that's 3, 13.
Divide by 2 again, or you could have divided by 4 originally and got to 3/13. Now I also want to get the percent. How do I find a percentage from a fraction?
You divide it and then times it by 100.
You actually do the division and then you multiply it by 100. So in your calculator you're going to do 3 divided by 13. What do you get when you do 3 divided by 13?
23%.
0.07. Now, I do want you to round correctly. So, if we want the 3 to be the one we're rounding, we look at the number after. If that number is 0 through 4, we don't change it. If it's 5 through 9, we would change the 3 to a 4. So we get 23% because we don't need to change this. So these are the 2 answers I'm looking for, the percentage and the reduced fraction. So I want you guys to try a problem really quick. We are still working with cards. The roll 1 die is information for later. That is not part of the try problem. The try problem is just the probability of getting a red card when you pull 1 card from a deck of cards. On our try problem, what did you get for your original fraction?
26 over 52.
26 over 52. What does that reduce to be?
13 over.
That's not fully reduced. 1/2 is the fully reduced. 13 over 26 can both divide by 13.
I said that, Lindsay.
Are you?
Oh, thanks.
You get the decimal 0.5. What is the percentage? This is the mistake I'm seeing most often around the room. 50%. You move the decimal 2 to the right. So you have to add a 0. I saw some people put 5%. I saw it actually a couple of times, which is why I'm bringing it up. You need to make sure to move the decimal 2 to the right. So, as well as working with cards, we also would work with dice. So we need to know the total possible ways we could roll dice. Now, we're working with a standard dice. We're not working with like a 20-sided or a 12-sided die.
Those weird dice.
So, if we roll 1 standard die, how many possible ways could we roll 1 standard die? 6. It has 6 possible outcomes because it has 6 sides. Okay, now rolling 2 dice can be a little bit different. How many possible outcomes do we have for our first roll? 6. How many possible outcomes do we have for our second roll? Another 6. What do we do with those 2 6s to find the total possible outcome? What did we learn last time? We learned last time to multiply stuff to find total outcome. If we made a table, it could show us why we multiply instead of add. I could get a 1 and then a 1 when I roll my dice. I could get a 2 and then a 1 when I roll my dice. A 3 and then a 1. A 4 and then a 1. Or I could get a 1 and a 2. A 1, no, this would be a 2 and a 2. A 2, 3 and a 2. 4 and a 2. There are 36 different ways we could get 2 dice rolled. Guys, Josh. I did not. I was
Good.
busy
That
doing
sounded like
math.
the devil. Weird. It sounded like the freaking devil.
Okay? I still want you to be quiet. Okay? 36 possible outcomes when we roll 2 dice. Yep. Brayden, your cell phone should be away right now. Okay. So, let's do an example with our dice instead of our cards. Let's say we are rolling 2 dice, and we want to find the probability that when we roll those 2 dice, we would get a sum of 8. So we want total outcomes on the bottom, the outcomes we want to happen on the top. So how many total outcomes did we talk about for 2 dice?
36.
36. Then we have to figure out how many ways could I roll a sum of 8. What possible options do we have?
2 plus 6.
2 and 6 would add to 8. What else? 4 and 4. What else? 6 and 2 would be counted differently.
Alright.
What else?
4
5 and 3.
5 and 3.
This is
4
ridiculous.
and 4. It doesn't
3
change
and
if we flip it.
5.
You can do it.
And those are all our possible options.
There's 5.
Okay? So how many do we have total of our favorable
Five.
outcomes? 5.
So that's just one.
So, right, and I already said, well, that fraction, I can't reduce it any further. So, we go straight to the decimal and the percent. What do we get if we do 5 divided by 36?
0.1388.
138. So I do want you to round this properly, which would give us 14%. So we have one last example. So these are all kind of our gambling examples. You're playing games of chance. I could also do probabilities for a lot of different situations, though. We're going to change this to 2B, since we are working in 2B. So we're going to be using some of our counting principles from last time, where we figured out how to find how many different ways an outcome could happen. So our goal for this question, Mrs. Barton's 2B, is electing a class presidency. What is the probability that the presidency is all boys? Now, I could have done this differently. I could have said, what's the probability that our presidency was all girls? Or the presidency consisted of people who owned iPhones? Or the presidency all had glasses? There's a lot of different ways to ask this question. But the way we figure out our total amount is different. We can't just count up how many people are in the room and put it on the bottom of our fraction, because we're not using everyone in this room. How many people are we picking out of?
4.
I would say 3. We're going to do president, vice president, and secretary. We're just going to have 3 for our presidency. So we're picking 3 people out of all the people in the room. So we do need some information first, because we are doing it specifically for our class. We need to know how many people are in the room, and we need to know how many boys are in the room. So we need to count really quick. I want everyone to count how many people are in the room.
How many, like, just boys or girls too?
We want the total amount, and we want just boys for this question, since I asked specifically about a boy presidency.
I'm too lazy to count.
29? So 29 total?
14 boys.
And there's 14 boys? So our probability on this one is not 14 over 29. Guys, I need your focus again, please. We're almost done. Brighten, focus. Okay? All our other problems, we are only picking one thing. We were picking one card. We were rolling a dice once, or we were rolling 2 separate dice once. Here we're picking 3 people. So our total number of outcomes depends on the fact that we're picking 3 people out of the 29 people in this room. So when we were picking, to figure out our outcomes, we had to use either a permutation or a combination. Permutation order mattered, combination order did not matter. Which one is this? Permutation. Order matters for a presidency.
Oh, yeah, it does.
Yeah. So the total way we could just pick any 3 people from this room would be, sorry, that's too big.
You have to put your pen down. Let's go over this.
It feels like be 29, and we're picking 3 of those 29 people. That's just how many ways we could pick a presidency in this classroom. But the numerator is going to be different. If we're picking our presidency just from the boys, what would change about this? The 29 would change. We're not changing how many people we pick. We're changing how many people we're picking from. So now we're going to have to use our formulas to do this. We're going to have a fraction over a fraction on this. A permutation said n factorial. N was our bigger number over n minus r factorial. Same thing on the bottom. N factorial, but n changed, so we use 29, not 14. And we had to do our subtraction first. On the assignment, there's only one question like this. Most of the questions are the easy division. There's only one question that will involve our permutations or combinations. So we did our subtraction first. We have 14 over 11 factorials divided by 29 over 26 factorial. Now, if you weren't here last time, factorial just means take whatever number's written there and multiply as you count down until you hit 1. So like 11 factorial would be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or 14 factorial would be 14 times 13 times 12 times 11 until you hit 1. But we can plug this into our calculator. When we do, we have to plug the top fraction in separately from the bottom fraction. Now, since we did our class individually, I don't have the answers for this. I need your help. So I need some people to plug in the top fraction, 14 factorial divided by 11 factorial. And I need some people to plug in the bottom fraction, 29 factorial divided by 26 factorial.
2184.
2184 is the top. About the bottom fraction.
21,923.9 repeating.
There should be no 0.9 repeating.
Okay, well, let's try that again.
Is that a 21?
21,000 divided by.
There should be
It
no
has-
decimals.
That has a.
Yep, same thing. That's very odd. What's 29 times 28 times 27?
Times 28.
Yep.
Did you subtract right? 21,921.
Okay, it must just be your calculator having rounding issues because it's working with such large numbers. So,
iPhone suck.
okay. Well, it sounded like a regular calculator was doing the same thing, right? Did yours say 4, Colby, or did it say, okay, it just said 4? Yeah, so your iPods might have some issues rounding because the numbers are so big. Andrew, Abraham.
So is that the fraction?
Okay. So here's our fraction that we need to plug in. I will not make you reduce this one. This one's so big, I just want the decimal and the percent.
This is Ronald.
I said Abraham and Andrew, and I said Daniel. I did not mention Ronald, actually.
Yeah, Abraham was just standing there looking out the distance like this.
Well, then I thought Abraham was talking, so I said his name. But I know who Abraham and Ronald are.
Yeah, Ronald.
Okay? Either way, I want you to plug this into your calculator. 2,184 divided by 21,924.
So it's point, yeah.
What do you get? Point what?
Point 0.09.
0.99, so
That's
10%.
10%.
So we have a 10% chance of, if we randomly picked our presidency, we didn't vote on it, we randomly picked on it, then we have a 10% chance of getting all boys in the presidency. So again, this last question, there's only one question like this on the assignment. The rest are the easier types of probability.